So let's say that somebody tells us that they measured out 30 grams of that phosphoric acid, and they want to be able to convert that into the number of moles of phosphoric acid because, I don't know, they wanted to do some reaction that requires exactly that amount. And they want to know how much of some other reagent to use, let's say. So what we're going to do is we're going to remember a dimensional analysis, and I'm also going to write down the formula mass of this thing, molar mass of that thing, which we calculated previously. And I'm going to write it out as kind of an equality so we can kind of start to think that, all these molar masses are really just conversion factors that I have to probably use in some sort of dimensional analysis. So if I remember correctly, my value for this thing was that when I calculated it from the periodic table, I know that exactly 98 grams of H3PO4 equals 1 mole of H3PO4. So what I'm about to do is set up at that dimensional analysis, and you'll notice that a lot of the steps that we talked about are pretty much the same. I start off with my value of grams over 1. I put a conversion factor there, and I am going to keep track of where I would like to go, which in this case is moles. I'm just going to erase that thing right there because it's kind of getting in the way. And I will redraw it up above. So 98 grams equals 1 mole. Okay, so I've got my dimensional analysis set up. Remember, anything that's written as a numerator here, I'm going to put into the denominator so that it goes away. So I'm going to put grams there, and I recognize that I've got moles right there. And then, just like I did for any other dimensional analysis, I say, is there anything that relates those two numbers? And if there is, where does the 1 go is a really important question. So you can see here that we've got 1 that goes with mole. So the 1 goes with moles up here. And that 98 grams is going to go down here. And hopefully everybody can read that. Grams cancels out. And so what this tells me is that really what I would like to do is that operation in order to get to the number of moles. A lot of people like to just memorize that if you're given grams that ultimately you have to divide by the molar mass. I like to set it up as dimensional analysis, especially because these things are usually part of a much larger calculation. So what I would like you to do, plug that into the calculator and see if your answer agrees with mine. I'm not checking any of my work. I love having a captive audience. Number I ended up with was 0.306. I guess I should have rounded it to 0.31, but no big deal. The very next thing I'm always going to do, just like in the case of a metric system calculation, is I'm going to make sure that that kind of makes sense, right? And I'm going to look back at my conversion factor and remember, okay, so I needed 98 grams to get to 1 mole. Does it make sense that 30 grams is, less than that? Yes, it does. Does it kind of scale properly? Well, yeah, that's kind of like 1/3 of that. And so, that's kind of like basically 1/3 of a mole. So it sniffs right. So I'm pretty confident that that's right. Let's try one more, and then we'll try to do the opposite, which is to take moles and go to grams. Here's the next one, number 8 on the grams to moles resource guide. I've got 89 grams of this thing, which I've already calculated the formula mass. If you have questions about that, go back to the last video lecture. And we need to convert that into moles. We're going to take our 89 grams. We're going to put it over 1. Space for a conversion factor, going to moles. And then we just have to set up our units right. Grams are up in the top. Grams go in the bottom. Moles come over. Where does the 1 go? Well, the way I've written it right there, it might be tough to remember, but it's grams for every 1 mole. So 1 goes with moles. That goes with the number of grams. And so this is telling me that if I do the following operation, I will end up with the number of moles of that thing. So let's do that. So there's my answer. Does it kind of sniff right? Well, 89 grams is a lot less than that, and that is a lot less than a mole. So it looks good to me. All right, let's do some moles to grams conversions now. Okay, here is our next kind of conversion that we are going to have to be conversant in. In this case, we start off with the number of moles. It happens to be for this thing called benzene. Obviously, you would have to calculate the formula mass of this thing. I did it for you, hopefully even correctly. And if you have any questions as to how to calculate those, be sure to go back to the other lecture video. In this case, we're going to go from moles to grams, and you'll notice that the setup is no different than we saw before in terms of setting things over 1 and setting things up in terms of the units you would like to go to. Moles needs to cancel, so we're going to put moles down here, grams in the top. And then, so what we'll do is we'll take that 1 mole and plug in that 78.12 there. And let's see, when I did that, I ended up with 437.47. I think, yes. So what this is telling us hopefully makes sense. You'll notice that really it's similar to what we just did in terms of taking grams to moles. It's just that now you're multiplying instead of dividing. You still want to make sure, or you still want to look at that number and say, okay, well, I know 1 mole was 78 grams. I actually need a whole bunch of moles of this thing. So does that kind of jive? Nah, give or take, I think it does. So I'm not going to do another example of this. If you need another example, please come to office hours. I'd be happy to help you out. I will post answers to all of these resource guides so that you kind of have built-in study practice.